Hi, good day. My name is David Butts. I'm joined with Rachel Williams, and we're here to discuss cold weather readiness as part of the Intrust Solutions Group webinar for November 2023. I am part of TG Advisors, and Rachel's part of Kestrel. These two groups are now part of the Intrust Solutions Group. TG Advisors is a network of experts with extensive OEM utility and engineering consulting experience who have designed units operating worldwide and develop novel service strategies and engineered major unit upgrades. Kestrel, very similarly, is a highly specialized consulting service company developing innovative solutions for the North American electric market. Kestrel provides a full complement of consulting and training services, as well as on-site testing and tuning services designed specifically to address regulatory compliance. How have you known these companies in the past? There are some people that know TG Advisor through their work on their steam turbine. Kestrel, you may have heard of for their work on inspecting your generator. As I said, both TGA and Kestrel are now part of the Intrust Solutions Group. Introduction for David and Rachel. I'm David. I have 20 years of experience in the design and manufacture of gas turbines with General Electric. I have expertise in EF and HA class GE frame turbines, and Rachel has 19 plus years of power gen experience in the plants with Tucson Electric Power and 10 years of NERC compliance. I'm currently with TG Advisors. Rachel is currently with Kestrel. Our agenda for today's webinar, we're going to discuss extreme cold weather background, regulatory agency requests, cold weather concerns, weather planning. We'll have a summary, and then if there's any questions for those left awake, we can answer questions. Extreme cold weather background. So recent cold weather events, January, February of 2019 was what was called the Midwest Arctic Polar Vortex. Now, it's not impressive, but downtown LA never reached greater than 70 degrees for the whole month of February, which is a pretty significant event for LA. Chicago was minus 23 degrees with wind chill of minus 52. More recently, February 2021 was Winter Storm Uri. During this event, there was 4.5 million homes and businesses without power in Texas, a record low at the Dallas-Fort Worth airport of -2. Keep in mind, this is Texas. And it was estimated that just over 700 people died in Texas due to the cold weather event. December of 2022 was Winter Storm Elliott. This had single-digit temperatures in the southeast. December 23rd, which is right before Christmas, 1.5 million customers without power. Each of these events significantly strained the electric infrastructure, causing inoperable utility equipment and power outages. All of these events impact our day-to-day lives. I am now going to pass it over to Rachel to discuss regulatory agency requests that came out of these events.
Okay, thank you. It's great to be here with everybody. And cold weather is something that is becoming more and more of a big deal for NERC. So this presentation, or my part of the presentation, is going to be mostly aimed at the NERC requirements. So weather is wildly unpredictable, and NERC is seeing that more and more in historical weather patterns throughout the US. In fact, just this morning, I woke up to snow in Arizona, and I do live in kind of a colder environment, but it's November, and usually we don't have a lot of snow in November here. So all of these changes with weather are making NERC have more and more concerns about people being ready for cold weather, and especially in the power plants, because when the electricity goes down, everyone is suffering. So right now we have two standards that are being looked into, and one is enforceable. The one that's enforceable now is EOP 11-2, and it only has two standards, but it is developing into EOP 12-2. So, and it had EOP 12-2 hasn't been voted on to be enforceable yet, but it's coming. They're saying October 1st, 2024. So EOP 11-2 and 11 and 12-2 are very similar in the requirements that are currently existing. So the two requirements for EOP 11 are R7 and R8, and they are pretty much written in identically into EOP 12-2. So they say essentially that you have to have a cold weather prep plan that has to be site specific. That's very important. Or unit specific. It actually needs to be both. There's going to be criteria that is more for your site and then criteria that is unit specific. And you have to meet that criteria for every unit. And the same goes for training. NERC is not looking for generic trainings. They are looking for site-specific trainings. What is going to impact you? And letting your people know what's it going to impact you so they can be prepared for it. David, if you'll scroll us. Okay, thank you. Okay, EOP 12-2. It's becoming effective October 1st, 2024. One of the things about EOP 12, I think a lot of times when NERC brings out standards, people think, oh, it's not going to be that big of a deal. It's just one little standard. But I think the way that they've taken cold weather is exactly the way that NERC is going. It starts out kind of minimal and then it increases. In cold weather, we're seeing that tenfold. With cold weather in EOP 11-2, we had 2 requirements. In EOP 12, there's going to be 8. So it's not going to get better. It's just going to get worse. There is an implementation plan. So some things will be due when the standard becomes enforceable. Other things will have phased in implementation. And it's important that people understand and utilities understand that criteria. So in R1, they're requiring that everyone calculate their extreme cold weather temp. So that is, if you haven't done that, that is something that you should start looking into right away, because it does take some work to get that rolling. In addition, the requirements that you saw in EOP 11-2, R7 are also going to roll into R1 of EOP 12-2. So you have to develop your cold weather prep plan, and it has to include the criteria in part 1.2, and it is identical to EOP 11-2 R7. So if you have done that, the biggest thing you can do right now is start reviewing. For R2, this is going to apply to new facilities. And you're going to, for new facilities, you're going to have all of your freeze protection measures in place by October 1st, 2027. They do give some specific criteria that includes things like wind speeds and other circumstances that can affect your cold weather. So just because maybe you get to freezing at 32 degrees Fahrenheit, that doesn't mean that that's the only thing that has to be included. You have to include and you have to consider things like wind. And when you've had really windy seasons, you have to determine if you need to make some additional precautions to account for things like major wind. So that's what R2 is talking about, is taking into account your extreme cold weather temperature that you calculated in R1 and bringing in some other factors, and then figuring out what freeze protection measures you need to take to become compliant with the standard. R3 is freeze protection measures for existing facilities. So R3 is telling you that you have to be compliant by October 1st, 2024 to meet the criteria of the standard. So if you have an existing facility, now is the time to be thinking about your freeze protection measures. And the way that NERC does a lot of these standards, and especially with what we're seeing with cold weather, is they put the information out there and then they give you some time to prep. So I feel like what they're doing with especially R3 is they're saying, here's your opportunity to go through a cold weather spell or season right now, and then see what works, see what doesn't work, and then make some adjustments. And you have until October 1st, 2024, if you have an existing facility, to do that. So you've got to develop a plan to make the necessary changes or modifications or add additional equipment that will help you get through the cold weather seasons. Okay, R4. So R4 again goes back to your cold weather prep plan. And it kind of outlines exactly what they want to see in your cold weather prep plan. So the first thing that they want is for you to include your extreme cold weather temperature in your plan. If you've done that, that's great. If you haven't, you should probably start thinking about either finding somebody to help you or doing it yourself internally. The second thing, you will have to include the cold weather data in part 1.2 of the standard. You will have to identify a cold weather critical component list and have that in your plan. And then they're wanting you to identify what different cold weather effects you're going to have for either wind, sleet, snow, ice, and then they want you to take into account what you need to do to make the changes that need to happen to account for different effects of freezing, different freezing challenges that you might see. So the things that they're looking at are the effects of wind, the effects of sleet, snow, ice, freezing rain. Some of those things could even include having a plan if you're in a remote area and you can't get to your site. So they just want you to take into account all the different things that might happen if you get into an extreme cold weather situation. And then in your plan, you need to document that you will have an annual inspection and that you'll perform maintenance on your generating facility to account for your freeze protection measures. Okay, R5. R5 is identical to the wording from EOP 11-2. So it applies to the generator owner and operator, and you're just required to do site-specific training so that your personnel know exactly what they need to be looking into to be able to account for all the freeze protection measures, and that they'll be aware of different things. It could be as simple as shutting a door in a heated area, making sure that covers are put in place, simple things like that, heat traces is in place and operable, different things like that. And having all of those accounted for, but then letting your people know that that's part of what's going on. So just making some awareness can help. Sometimes you can get people on board just by saying, hey, this is something we have to do. Please help us get it done. R6 takes into account that, excuse me, that when if you have what they're calling a generator cold weather reliability event, and they've got specific criteria around that, you are going to have to develop a plan, a corrective action plan, to account for why you were part of that cold weather reliability event. What happened at your facility that caused you to contribute to maybe loss of generation, or maybe you couldn't start up because you had freezing issues. They're just wanting you to know that it's no longer just going to be like, oh, well, we got to take care of that next year. You have to do it right now. You have to have a plan in place to figure out what you're going to do so that you don't do it again. And they've got specific criteria around that. Okay, and then R7 is corrective action for all of the things that happen in R1, R2, R3, and R6. So if you have anything that goes on in one of those different requirements, if you have an issue and you can't cover it, then you have to develop a correction active plan and implement that plan and take care of things. So I know a lot of times in the plants, what happens is things get pushed out. Let's be honest, they just do. People have a million things going on, and it's always, well, we'll take care of that later. We can get to that next year. What NERC is really saying is that they're taking this seriously, and you can't just put it off till next year. You have to do it now. You have to be ready to take care of things and address them. It may take some time to implement things, but you've got to develop a corrective action plan and get that in place so that you don't continue to have issues. And then R8 just says that they want you to not just implement a plan and just leave it out there forever. They want you to review it and make sure that the things that you have in place are truly what's going on. For example, like I just said, we had an unseasonably warm summer, and everybody predicted that we were going to have a fairly warm winter, and everybody was wrong, at least so far. It's cold where I live in Arizona, which is not usually the case, especially the end of November. We tend to get a little bit of a warmer spell, and I woke up to snow 3 times this last week. That is an unusual situation, even for our little mountain community. They want people to have things in place, and then they want them to not just say, well, last year we did good and everything went fine. They want you to count, what could your possible cold weather time be, and get things ready in those times. Maybe you have to kind of modify as you go, but if you at least have things in place like portable heaters, heat trace ready to go, shelters that may need to be built, or doors that need to be closed, start thinking about those. Let your people know and review your plan and your training every year so that you can be ready for the next year. Okay, David, can you go to the next? Okay, so this is my friend Stone Cold. So the bottom line is that EOP 12-2 is not a suggestion, neither is EOP 11-2. They are required. GOs and GOPs need to be ready because it's not getting easier. It's just going to get worse and worse, and there's going to be more and more requirements, and especially if people ignore this. So it's very, very important that you start now, you get things going, because it's not going to get better. It's not going to get easier. You might as well know what's in the standard, reach out to somebody who you know, who's familiar with the requirements, who can help you, and let them help you. Or, whoever that might be, figure out who the best people are. When you're talking about your plans, don't forget to include your operations and maintenance crews. They know what's going on in the plant. Talk to your supervisors in those areas. They will know. They'll know where you've had issues, and they will help. So don't discount your own personnel and then, whatever additional help you might need. But I just feel like it's important that people understand that nothing's going away, nothing's getting easier, nothing's getting better. It's only going to get worse. And if for no other reason than because NERC said so. So don't put this off. The earlier you prepare, the better off you'll be. If you wait until September of next year, it's going to be very hard for you to meet compliance with this standard. Okay, so hopefully this isn't the first time that people are seeing this. NERC put this NERC alert out in May 15th, 2023, this last May, and it was considered a voluntary effort. Obviously the internal joke within probably every organization is there anything truly voluntary with NERC? Maybe not, but it is important that people understand that NERC put this out because they wanted to give you a little window into what was coming. There are additional requirements that were not in the NERC alert that are going to be part of EOP 12-2, but this is definitely a very good start. So if you did your NERC alert, you're in a pretty good position. You're still going to need to make sure you understand all of the requirements of the standard, but this NERC alert really helped to guide people to where EOP 11 or EOP 12-2 is going. So just ask yourself, have we completed our NERC alert? How much effort did we truly give it? And if you can say, hey, we did a really good job, then you're probably in a good spot. Review your plan, review your training, make sure all of the criteria for EOP 12-2 is there, and you'll be in good shape. If not, I would strongly suggest that you consider pulling up EOP 12-2 and going through it extensively. Okay. Okay, so I always just like to remind people that unless you're this guy right here, he looks like he's got plenty of money to throw around. Unless you're him, you probably don't really want to get a NERC violation that reports in a fine. So, and I just like to remind people that fines are capped at $1 million per day per violation. So it's not cheap. And I think anybody who's been in the industry a while knows that fines are rarely that expensive, but it's scary because you don't know that they won't be. A lot of standards that had never really had any penalties and violations associated with them are now getting some pretty big fines. And so I would suggest that if you even have a question as to whether NERC or your regulatory entity your regional entity will fine you, go and look at the most recent standard notice of penalty, and you can see that they are fining people, and it's not fun or cheap when it happens. So just don't forget, think about this guy. Unless you've got lots of money to throw around, don't get a NERC violation.
All right. Thank you, Rachel. So, having discussed the EOPs and the associated requests from the regulatory agencies, we're now going to transition to discussing some common cold weather concerns and how to address them in the facilities. So we'll just start with the fuel system. So the fuel supply is typically outside the scope of our assessment. Natural gas is recommended to be maintained above 40 degrees Fahrenheit for proper fuel nozzle operation. This is to minimize the condensation of hydrocarbons and moisture in the gas. Best practices are ensure your gas lines are below the freeze line. Insulation of the main supply valve is a good practice. The moisture filter drain line should be protected to avoid freezing. And if you have coalescing filters, they should be checked if there is increased accumulation. Typically, most sites have an insight from the previous winter's operation regarding how much condensation was pulled out via the filters. Liquid fuels will have their own minimum temperature that needs to be maintained. The two pictures at the bottom of the slide show insulation applied to a natural gas supply valve. Picture on the left shows a line of the pipe is completely insulated. On the right, there is a more local insulation application. In both cases, valves are insulated. Gas turbine inlet and bell mouth. So inlet icing and snow accumulation can cause excessive pressure drop, causing unit derate or trip. Well-sized hoods should be used to protect the inlet from snow. Coalescing type filters, if used, should be removed before winter. Note that compressor bell mouth icing can occur when inlet air is cold and humid, but actually above freezing. Isentropic acceleration of the air can reduce air temperature as much as 4 degrees, meaning that even though it's 36 degrees out, you could have conditions for icing within your bell mouth. A viewport can be added to observe the bell mouth. Note, icing can be a source of FOD. If icing occurs or a history of icing is known, inlet air heating can be added. The bottom left picture is an example of a bell mouth viewport. We have seen more field expedient viewports that aren't this nice, but this is a pretty good one. The center picture is an air inlet with inlet heating. There are multiple ways to have this heat generated. There can be an extraction off the compressor. You can actually extract air off the turbine enclosure room itself. The picture on the right is a inlet hood. There's many different styles out there. You can actually see the multi-layered hood in the center picture. The inlet hood on the rightmost picture is a more, I guess, traditional single hood style. Turbines and generator. Gas turbine performance improves with lower temperatures. There are bleed valves and purge valves depending on your configuration that can freeze. If valves are inside the enclosure, that can be a good form of protection. It is recommended to heat the turbine enclosure. A good practice is to place the turbine on turning gear at sub-freezing temperatures. Note that the timing of any seasonal combustion tuning should reflect current weather patterns. This is dry low emission specific. This tuning does more than just account for changes in the ambient temperature and humidity. It can also account for seal degradation that makes combustion systems more sensitive to the cold weather operation. Just because there were no issues with the combustion systems and reaching emissions during cold weather operation last winter does not necessarily mean you won't have a problem this winter. Recent discussions with our customers ran into a couple instances of units having issues due to the cold weather tune not being sufficient. Steam turbine performance is not impacted by the cold weather. This excludes issues with the steam delivery system. Generator output improves with lower temperatures. Generators typically have internal strip heaters to ensure moisture levels are kept low. Regardless, there should be a dedicated enclosure heater to regulate the enclosure's temperature. Some units do have minimum stator temperatures to protect the insulation. This ties back to a point Rachel made about ensuring doors are shut. This can also apply to enclosure louvers. They need to be checked for functionality. Picture on the left is of a gas turbine enclosure. Picture on the right, there's an enclosure heater in the bottommost portion of the picture. There's various types of enclosure heaters. Typically, they're mounted up in the upper corner of an enclosure. There can be more than one depending on enclosure size. Plant air, valves, and instrumentation. Plant air must be kept free from humidity. Compressor drains should be kept from freezing. Air dryer should be capable of dropping the dew point by a minimum of 18 degrees below the ambient. This is an ISA standard. That is a recommendation. It's not a requirement. The Instrumentation Society of America suggests having your dew point 18 degrees below the expected min-ambient. So there's a couple different options for air dryers. We recommend the desiccant air dryers. Those have some typical capability of -40, -60, or a -100. There are different kinds of air dryers, the refrigerant style, and those typically have issue meeting ISA standards, even in the southeast where it's typically warmer in the winter. All critical valves should be insulated. Pressure and flow transmitters for water systems should be protected in boxes with heat for temperature regulation. Sensing lines for water systems should be heat trace and insulated. A note on heat trace is you should ensure that it has been sized for the equipment being protected. We recently had a discussion with someone who actually had too much heat trace applied to a sensing line, which actually boiled the water, uh, giving them erroneous measurements. And this was somewhat problematic during the cold weather because it was up on the top of their HRSG. The picture shown here, the lower left picture is what you don't want, a very frozen valve. The centermost picture shows a protective box for some transmitters. There are O'Brien boxes and O'Brien style boxes that provide protection against both wind and help regulate the temperature of the equipment. The rightmost picture shows heat trace sensing line junction box. Note here, the failure of small valves and drains can cause very large problems. So it's not that necessarily the gas turbine does not work. It can be a drum level sensor goes down. It can be that the plant air compressor drain freezes, so you lose your air. There can be very small components on the facility that their failure actually takes down the full plant. So the attention to detail in the winterization plans is important. Typically, you can leverage successful past operation or past unsuccessful operation to understand where your weakest link is in your equipment. Now we'll discuss winterization methods. So all necessary water systems need to be protected. So typical ways of doing that are insulating water lines with heat trace. You can also use recirculation from a warm water source. And a good example of this may be a 50 to 60,000 gallon DMIN tank on site. And potentially you're able to cycle water from that DMIN source back through the line. That large tank, a good example would be, let's say, the southeast, where cold weather events typically do not last for weeks at a time. It could be a couple days at a time. That large tank will stay warm during that event, so the circulating water can be a good way to keep the water from freezing. Cooling systems that use water wherever possible should have a glycol water mixture to drop that freeze temperature. If you have a DMIN house, a water treatment building, that should be enclosed with heaters. All unnecessary water systems should be shut off and drained. So if you have inlet cooling, fan sprays, etc., typically these are not used during cold weather operations, so their failure wouldn't necessarily take down a unit. But depending on where you're operating, for example, Texas, just because you had cold weather one day doesn't mean you won't have warm enough weather within a week to necessitate using the inlet cooling. So draining and laying up these systems can ensure you have uninterrupted or avoid any derates due to failures of these systems. Prevailing wind direction should be understood and windbreaks installed accordingly. Most sites can have a variety of winds. Depending on your geography, you may have a single prevailing wind direction, but typically wind protection should assume the wind can come from any direction. If you have temporary enclosures, or you can make temporary enclosures with roofs, you can install those around key equipment as necessary. Critical equipment and drains need to be protected with portable heaters. So upper right-hand picture is a salamander style heater. Middle picture, that's a heat trace indicator light. You can have more complex systems that automatically test a heat trace once a day, but this light system can be used during rounds to validate system function. The bottommost picture is an example of a windbreak around a skid. It's got walls and a tarp over it. This can be used to help protect equipment. Once again, all these are implemented to avoid failures due to the little small things. I'll take a special note on combined cycle. So combined cycle units can pose an extra level of complexity due to the number of systems handling water. Water is below 32 degrees, water freezes. The circulating water system and the HRSG and associated systems they're going to have a lot of water in them. Now, your HRSG, depending on where it is built and when it was built, may be within a building or it could be fully exposed. The bottom leftmost picture shows a typical HRSG in the south. It's just fully exposed. It's not in a building. The winterization methods and processes used for other water-based systems are applicable to the combined cycle plant. There's just a lot more need for that protection. And there are many cold weather critical sensors, valves, and equipment. Now, depending on your plant configuration, key equipment could be in the basement of a steam turbine building, which could provide significant protection for a good amount of your critical equipment. There will still be lots of sensors and valves around the plant, especially on the HRSG and on top of the HRSG that need to be protected. Like mentioned previously, the bottom leftmost picture is an exposed HRSG. The centermost picture shows circulating pumps, and the rightmost picture shows cooling towers. Typically, rounds for a combined cycle plant include walking through or by all this equipment. The effective wind, as Rachel mentioned in EOP 12-2, and which has driven regulatory requests coming out of ERCOT, is accounting for the effective wind. So freezing temperatures combined with high winds will reduce the time to freeze. If ambient temperatures are above freezing, the wind will just reduce the time to reach that ambient temperature. But the major concern is when your ambient is below freezing. High winds means whatever is unprotected will freeze faster. So stagnant and unprotected water lines are highest risk. You should drain and purge any water lines not in use. Critical equipment should be protected with features to block wind, understand and account for prevailing wind direction, but typical wind breaks really just assume the wind can come from any direction. So here are 3 examples. So the bottom leftmost picture is a scaffold wrapped in plastic. So this is a temporary solutions. You can bring in a crew to set up the scaffold and wrap it in plastic. The centermost one is not a scaffold, but a metal frame that has plastic wrapped around it. You can see a portable heater in there. And then the rightmost picture is a permanent enclosure installed around an air compressor. So currently the doors are open, and this is the door configuration that would be used during summer operation. I think this enclosure actually has a temporary window that can be opened up. But during winter operation, doors are shut, the window is shut, and there could be a heater placed in there to ensure that the compressor has no interruption due to cold weather effects. If not accounted for, sustained winds can defeat previously effective protection. This is why EOP 12-2 does have a separate call out for addressing wind. It's not just about understanding the ambient, it's also about understanding the effects of wind and precipitation. Now that we've discussed cold weather concerns, we'll discuss weather planning. So weather plan components. Sites should maintain a plan appropriate for plant location. And these are the items that we think are important for a good weather plan, and they're also very consistent with what you read in EOP 11-2 and 12-2. So a good weather plan should include the following: revision control. So you can update your document and confirm and ensure everyone is using the same version of your document and ensure it is the latest version of the document. These should be treated, weather plans should be treated as a living document, so you should be able to change it. That should not be a barrier to making improvements, but ensuring that you have some sort of revision control. Make sure that everybody's on the same page for which is the latest process and method. You should document your historical min and max temperatures. So location-specific record temperatures. This is the ECWT that Rachel talked about. You could also document your successful min and max operating temperatures as well. Equipment list should be part of this weather plan, so weather sensitive and critical standard plan equipment. You could also list out additional weatherization supplies and equipment, so go boxes, go bags. What type of stuff should you get together and where should you stage it? You should have a list of responsible parties, who to contact for what type of issue. You should have staffing requirements that are associated with the plan implementation criteria and phase. So what is meant by time and temperature could be starting in October, we're going to call up our vendors and schedule them to come out and install the scaffolding around all the equipment we have decided we want to wrap in plastic. So there can be calendar-based criteria to implement some amount of your cold weather plan. Then it could be potentially in November, you do phase 2. Phase 2 may be go and drain the inlet chiller, lockout tag, lotto it out, take it out of commission. And then you could have temperature-based criteria for your plan implementation. So for example, when it becomes 40 degrees, implement winter rounds. When it becomes 40 degrees, bring in an extra person on shift. And then another item, go turn on the heaters. And then below, you could have another level of temperature requirement that below freezing, you have increased rounds, increased staffing requirements, and maybe more aggressive checks of critical and key equipment. The weather plan should have training requirements, at least annual. Typically, this could be part of your plan implementation in addition to gathering key supplies in October, calling your vendors, maybe getting an air compressor and an additional generator. You could also do your annual training around this time to get everyone prepped before the cold weather occurs. Checklists are a very powerful way of ensuring key items are done. In a heat of the moment, it can be easy to forget something. So there should be checklists to help you prepare for the cold weather. There should be in-action checklists, and there should be post-action corrective action checklists. A big part of the effectiveness of all these weather plans is being able to roll in lessons learned from previous winters. Not every winter will have the same issue, but typically as you improve the cold weather capability of your plant, you will then highlight whatever the next weakest link or the next item that have an issue could be. So once you address all the sensors on the top of your HRSG and the plan is more capable, you may determine there's some other issue that you didn't know about. Note that a weather plan should account for both a running and idle plant. Now, I would say most plants have a typical operational profile. They know that they are typically peaking plants. We are called when weather is very hot, or we are called when weather is very cold. They could be a combined cycle plant that is always on or dispatched prior to a cold weather event. But these plans should, to account for changes in your operational profile, understand how to appropriately weatherize your plant when it is running and when it is idle. The requirements needed for a dry low emissions peaking plant, or the scope of cold weather protection for a dry low emissions peaking plant, can be very different from a combined cycle plant that utilizes water injection to control NOx on the combustion turbine. This is the summary. So our weather readiness services. So we can help with cold weather compliance requests, NERC, ERCOT, CAL-ISO. Our engineering assessments of site weather readiness accomplish 3 goals. Now, although there are 3 goals, you don't have to necessarily do all of them. You can choose these separately, but typically these are the 3 items we will address for a customer. So we'll address the plant's current min temperature capability and address the regulatory body request. We'll identify equipment limitations and opportunities for improved robustness. And we will review a plant's cold weather preparedness plan and provide feedback about freeze protection measures. Typically, in our most recent visits, most sites have pretty legitimate plans. Everyone kind of understands the direction NERC is going. Everyone has, if you're in the ERCOT market, you have received specific requests for the site min ambient capability and most recently wind chill capability. So everyone has started developing these plans and has taken more seriously cold weather winterization. Having said that, it always helps to have an independent engineering assessment to help provide additional information. Our assessments are a combination of operational data analysis, so data historian or PI data, review of plant maintenance records, a on-site plant walkdown, engineering calculations, and expert experience. When we visit the plants for the walkdowns, we like to spend time talking to the operators. There is a lot of experience on site. We had a recent visit to a plant, very complex, but we were able to talk to someone who had been there for approximately 30 years. They had very good insight into the issues the plant had addressed over time. and the current state of the plant's winterization efforts. We can also help address requests from EOP 11.2 and 12.2. For example, determine the plant's extreme cold weather temperature, the ECW2, like Rachel discussed. It's something, if you wanted to, you could do it yourself, or you could call us and we can help you walk through that. Note that NERC has published a PDF that goes over how to calculate that ECWT. It's a pretty good document, lots of screenshots showing how you pull the NOAA data, how you use Excel. But if you don't have the time or you have other stuff to do at the plant, you could call us, we can help you. The bottom picture is an example of our winterization plan scorecard section. So we can look at your winterization plan and provide comments. So we list out various components we feel are important: training requirements, in-action checklists. Does the site meet it? What does TGA recommend? What's your readiness score, and some comments. So to reiterate, we can help with cold weather compliance requests. There's a lot going on right now. I think most people have dipped their toe into it, and we could help go forward to help everyone reach that October 24 date and feel comfortable. So in summary, preparation and planning is critical for plants to remain operational during cold weather events. Regulatory requirements for cold weather capability are here to stay and are becoming more rigorous. Like Rachel said, this is not going to get easier. This is only going to get harder. And everyone should be working now to be compliant with EOP 12-2. It is rigorous and detailed. Rachel went through that full list of items. There's a lot there. Keep in mind, October 1st, 2024 will be here sooner than you think. Rachel, do you have any additional comments?
Maybe just one little comment. One thing that I'm seeing with the NERC standards is that people are struggling developing a decent training program that they can carry forward and continue to use, and that is meaningful to their plant. So that is another thing that we could help with if needed, is we could help get you some training in place so that your people can do something that's effective, that doesn't take a long time, but that will help you with compliance. It's the only thing I have.
And that's part of EOP 11-2 currently, or is that in 12-2?
It's in both.
It's in both.
So if people are struggling with getting their training and making it valuable, that's something we may be able to help you with.
We're typically there to help supplement and help out because plants are busy running a plant. This type of stuff is new scope, or the scope required to become compliant with these EOPs is a bit more time than people have typically allocated. So we can be there to help out. Are there any questions? We are now at the end of the presentation. If there are no questions, we are done for this webinar, and we thank you for your time, and thanks for listening to our 2023 webinar series, Cold Weather and You. Thanks.